Okay, chemistry, this is Thursday, May the 14th, the last day of my instruction. Isn't that great? Yay, next week, the last week of the school year, you're going to have ACT Academy for the first 2 days, and then the second 2 days, you'll have YouTube videos that are around 5 or 6 minutes long, and you'll enjoy them. It'll be fun. Okay, so today, I'd like for you to get out your packets, please, and get out lab number 2. This is where we calculate the mass, the percent by mass of acetic acid in vinegar. And this is great value. And if you take a look right here on the package, you're going to find a statement that says diluted with water to 5% acidity. That means it's 95% water, only 5% acid, acetic acid, called vinegar. Now, what they did was they expanded the base of the bottle, so it's a little fatter, and there's a longer neck above it. So they cut it down a little bit on the neck. I mean, they extended the neck, made it fatter on the bottom. So you felt like you're getting more vinegar. And then they reduced it from 5% acidity to 4%. They did that several years ago. And so it is a marketing scheme that you'll learn about when you take your business classes. Okay, so we're going to go ahead and titrate with sodium hydroxide, just like we did with the first titration with hydrochloric acid down here and sodium hydroxide up there. We're going to now have vinegar down here and hydrochloric acid up there. So let's go ahead and take the cap, the dust cap off, boom, off the top of the burette so that you can get good drainage. And then we're going to go ahead, it says, and balance the equation, of course. So acetic acid, let's take this stuff up here first. That is sodium hydroxide. Acetic acid is CHCOOH. You remember that? CHCOOH, CH3COOH. And so what are we going to get? Oh, wait, put the H up there, Mr. Schultz. What's your problem? Okay, there we go. Now, what are we going to get? We're going to get a salt and water, right? What is the salt? The salt is the sodium acetate. That's CHCOOH without the H on the end. And the water is the H2O. Okay, this might take a little longer today, so stay with me. All right. We're going to go ahead and say 1 sodium, 1 sodium. We're going to go 1 carbon, 1 carbon, 3, 1, 4, 5 hydrogens, 3, 4, 5 hydrogens. 1, 2, 3 oxygens, 1, 2, 3 oxygens. Looks like it's 1, 1, 1, and 1. Nice. Next, mass about 3 milliliters of vinegar. Okay, I'm going to use a 10 milliliter graduate, and I'm going to pour in there about 3 milliliters of vinegar with my steady hand. Now, first of all, I'm going to turn on my balance. I want to get the weight and the volume at the same time. It's going to be really easy with an electronic balance. Put it on there. I'm going to press the tare button. That zeroes it out. And then I'm going to pour in there approximately 3. It doesn't have to be exact. Well, let's go ahead and pour it over here. Oh man, that's 4.5. I'm going to go ahead and stick a little bit in here. I want a little closer to 3. Now it's 2.5. You know what I need? I need a little dropper. That would take care of this problem. Okay, it is exactly 3.24 grams of mass. This is the vinegar. And the mass of this vinegar is 3.24 And the volume of this vinegar is 3.21, I think. 3.21. So it's just a little bit heavier than it is big, which means it's gonna, kind of like sink down. I don't know, maybe it's a little closer to 0.24, maybe it's closer to, but it makes sense. It's water with stuff in it. So that it would be a little bit more massive than it is big. Okay, and now what does it say? It says to pour the vinegar into the flask. I can do that. Got to be an Erlenmeyer flask because that's what all the professionals use. And then go ahead and add a couple drops of phenolphthalein. We could use BTB. That would be bromothiamyl blue. But we're going to use PH. Those are affectionate terms. That's called phenolphthalein. And don't ask me how to spell it. So here we go. We're going to go ahead and drop a few drops in there. Notice it's clear because it's in an acid. And then we're going to go ahead and titrate this bad boy. But first, we got to get our initial burette reading. Our initial burette reading is 17 point, no. It reads bigger as you go down. So it's 16.4. Starting out at 16.4 milliliters of NaOH. So we are titrating acetic acid with sodium hydroxide. Let's go ahead and do that. And what color? It's going to be the same as before. It's going to be a lavender pinkish thing. So how do I like to do it? Now you do know that you can go ahead and squeeze this and raise it up and down. I'm going to twist there. Let's go ahead and get that a little over here so you can see it better. And then we're going to go ahead and twist and shove. Here we go. This will not take long. Before it flashes. So I'm going to go easy, easy. I'm starting to get a little pink. Whenever it splashes in there, it gets a little bit pink. So I know I'm coming close to the end point of titration. You watching me? I hope so. Whoa, I'm able to swirl it out. And when it takes like 20 seconds to swirl it out, you know you're reaching it really close. Now I'm down to where I'm splashing it in drop by drop. Whoop, still swirls out. Still swirls out. Ooh, we're really close now. Whoop. See how it only takes one drop to get there? And again, I overshot with the base. I'll put that up there so you can enjoy it. In fact, while we're doing this, why don't we go ahead and check it with your Hydrian paper just to see if it looks like it's basic pH. Hold on. You still there? Hopefully you're there, not in there getting a bologna sandwich. Oh yeah, this is perfect. You'll see that I overshot it to an 8. Whoop. I overshot it, not 7. I don't know if you can see that, but it looks kind of like lime green, like 8 would look. Okay, that makes sense. And then the next question is, what if I were to take this pH meter, an electronic device, and turn it on? Ooh, had it on too long. And stick it in there. What does it say the pH is? Is it 7 or is it over 7? There's 2 little probes down there on the bottom of this thing that determines whether or not it's a base or an acid. And then if it is, how strong of an ace or high the pH is. It looks like it's about a 10.5, which is above 7. So I overshot it into the basic range. Okay. Now, we're going to finish this bad boy up. How many moles of sodium hydroxide were used? Well, I got to read this thing. It reads 40.8. 40.8. So how many milliliters did I drain down out of that thing? Well, let's see. That's 40.8 minus 16.4. 24.4. Okay, so how many moles does that represent? Well, what's the molarity of this stuff? Wasn't it 1/10 molar? That's what I gave you. And I got milliliters and I got molarity. So that's the first step. The first step is molarity equals moles over liters. 0.1 equals moles over 0.0244. Sorry about that, guys. Back to me. Okay, now, if you cross multiply that, you're going to get the moles of sodium hydroxide is 0.00244. And so the question is, if it's a 1-to-1 deal, do I even need to do stoichiometry, or can I do this in my head? That's how many moles of this that I used. That I neutralized. I did that many moles that I neutralized. Okay. Now, what's the mass of the vinegar neutralized? Do you remember how to take moles and get mass in grams? Okay, that's real easy. That's a one-step problem. So we're going to do another stoichiometry here. We're going to take 0.00244 moles of this stuff. Big arms of love. Moles, CH3COOH. 1 mole weighs how many grams? Well, it's going to be 12 and 12 is 24, and 3 more makes 27, and 1 more makes 28. 28, and this is 32. What's 28 and 32? 28 plus 32, the molar mass is 60. 60 grams for every mole of acetic acid. So what's 60 times that? It's 0.1464. And that's grams. So that's how many grams of acetic acid that I neutralized. So the question is, what's the percent of the acid by mass? Take that number and divide it by the mass that I had to begin with of the vinegar, which was what? 3.24. So out of 3.24 grams of vinegar, I had 0.1464 grams of acid. Now multiply that times 100%, and you'll find out what percent. I'm going to divide it by 3.24 times 100, and I get 4.5 percent acid. Here's key words: by mass. That is the percent of acid by mass in this jug right here that was manufactured in Bentonville, Arkansas. Oh, that was where it was distributed. I don't know where it was manufactured, but someday you might be a chemical engineer that goes to the production line and calculates the acidity and says 4.5 is not good enough. We're going to go ahead and fire you guys. We're going to shut this plant down until you can get it right, because Mr. Great Value, Sam Walton, will not accept 4.5% because he's advertising he's got 50% in that kind of a package. See how much power you're going to have when you get a college education? Now, could we calculate the molarity of the vinegar solution if we wanted to? Sure. We could go molarity as moles divided by liters. How many moles of acid did you have? And how many liters did you have? 3.21 milliliters. Let's do it. Molarity is moles per liter, 0.00244 moles. And it was 3.21, so that's 0.00321 liters. Now let's go ahead and calculate that. 0.00244 divided by 0.00321. I get 7/10 molarity. Molarity is 0.7 molar. So the vinegar was 7/10 molar in concentration, and the sodium hydroxide was 1/10 molar in concentration. That's why it took like 7 times as much of the 1/10 molar to neutralize that thing. Now, it took a long time for you to listen to this. And your only one question I'm going to ask is, did you watch this video? And I hope you did. See ya.